Our progress into space will occur along 4 phases: exploration, utilization of space, colonization of other worlds, and exploitation.
Kraft A. Ericke, Director of Advanced Systems, now working on detailed studies of manned interplanetary missions to Venus and Mars and beyond.
To utilize terrestrial space by means of meteorological satellites, communication satellites, and similar devices. In the course of these 2 phases, we will have developed a space technology which will allow us to colonize other worlds. At first, these colonies will consist of small bases in the nature of outposts. But later on, these bases will contain a large number of people of both sexes. And people will be born, not only on Earth, but elsewhere in space. In the course of this colonization, we will have developed space transportation means so powerful that we can think of exploiting extraterrestrial raw materials. That is, making the entire solar system the raw material base of man, retaining the Earth as a biological center of a growing mankind. Now, which type of people are necessary to make such a program, such a development come true? They have to be people of vision. They must possess skill and knowledge. And most important of all, they must possess the art of blending the possible with the impossible.
But our purpose is not simply to measure man's level of tolerance and response to stress. Placing a crew in the loop in a near prototype, realistic breadboard of working hardware is the ultimate test and the definite bridge to early space operational capability. At the time we put this full-scale mock-up into operation, there were no available data on 3-man orbital simulation testing. Now it will be possible for a crew to experience most of the operational events from launch to landing. And now we can establish guides to hardware design and develop personal equipment, crew logistics, and crew training requirements. When connected with the IBM 7090 computer, we can simulate flight noise and vibration, couch and pressure suit restraints, and all biological environments of orbit except hard radiation, zero-G, and launch or re-entry hypergravity. Pressure suits, helmets, integrated seats, and restraints follow the design expected for actual flight. Incorporating dynamic control and display equipment, the launch and re-entry vehicle serves as sleeping quarters during orbit, and because of the 3-man crew size, is always inhabited by one of the astronauts. The second module contains the environmental control, food, waste, and sanitation equipment of the life support system. The shirt sleeve environment, with sea level, atmospheric composition, and pressure, is completely controlled by the crew from within. Part of the flight simulation includes emergency procedures to counteract environmental contamination and cabin decompression. The research module above includes displays, controls, communication, and recording equipment. In August 1962, we successfully completed a 30-hour test under simulated orbital conditions. In long-duration tests, ranging from several hours to several weeks, crew members will live on space rations and maintain normal rest, work, and recreation cycles.
These then are the beginnings of the manned space station program at General Dynamics. They necessarily include analysis, design, experiment, and verification across a broad range of technical and scientific disciplines, which we could only sample here. It's a continuing program and a challenging one. Our efforts are geared toward meeting that challenge.